Okay, we are live. Good morning, Mark Pinto here at Phoenixville Public Library, and welcome to our class today. Hope everybody's got their apple for the teacher. We're pleased to welcome Michael McTiernan to teach us all about Vedic math. Good morning, Michael. Take it away.
Mark, thank you. Good morning. This is not really a teaching event. It's more a show of what this math is all about. And then at the end, there are websites and applications that would allow you to download them and continue on your own. This is really, it's not something you teach. It's something you learn on your own. Let me just get started here and I'll show you what I mean. It's 800 years old. There's 31 sutras or procedures. It's mental, no calculator. The key to remember is the base that you're in. With a 3-digit number, the unit, tens, and 100s. And Vedic math, as opposed to what we learned in our schools, usually goes left to right, usually. Here's the agenda. I'm going to go over quickly all this stuff. I won't be able to take too much time because of the length. And this is the basic part of Vedic math. You can get into quadratic equations, whatever that is, or trigonometry and everything else using Vedic mathematics. The key is Vedic is mental. And these are the symbols that are used as a shortcut. And you may not need a pencil and paper. I think I've done that. I've explained that. This is why you might want to get into Vedic math or have your kids or grandkids do it. It'll set you apart on any kind of an interview you might have for a new job or admissions to a university. When you can tell the guys, you can read there that you can multiply 3 or 4-digit numbers in your head faster than the guy, the interviewer, can use a calculator. Again, be cautious of the subtitle. You do not learn Vedic math, you teach yourself. Same as basketball. When you're a kid and you want to learn basketball, somebody shows you the jump shots, layups, and then they walk away and say, practice, practice, practice. When you practice often, you'll teach yourself to be good at basketball on Vedic math. Essentially, there's no brains needed here at this level. It's memory, your recall. You just first got to remember to recognize the procedure and the base you're in. There are 3 magic numbers in Vedic math, 5, 9, and 11, and maybe 3. When you see those numbers, it usually is a different procedure than normal. Did we think alike? We could do this, we don't have time. All of you could pick a 4-digit number and rearrange the digits. Here's the numbers you 3 might have picked. Rearrange the digits with the largest one you can make of this number and then the smallest and subtract it. Same here. Start with 3 different numbers, you end up with the same answer. So it's just one of the things that Vedic math is figured out. It's 800 years old. And here's the one that was advertised in the precursor to the session here. You can have a 3-digit numbers. You start with 1, 2, 3, or you can start with any sequence of events, 4, 5, 6, or whatever. We're going to start with 1, 2, 3, and before we pick the numbers, the answer is 21, 21. It's a simple 5-number addition. If somebody, Mark, are you there? Somebody want to, so I'm not faking this. Give me a number.
756.
Oh, all right.
Yep, feel free to unmute yourselves, folks. That's fine.
756. Now I'm going to give a number. And that's going to be 2, 4, 3. All right, I need one more number. Anybody? Any number?
521.
All right. My number is going to be,
Can I predict your number?
well, there it is right there. Oh, yes, go ahead.
Is it 478?
No, 400, yes, 478. So you saw the pattern. So if you add these up, the answer is 2121. What this is called is it's a sutra, which is one of the categories. It's a complement of 9. Every number you pick, I subtract each digit from 9, and that becomes my number. And you can do this if you wanted to have you could do the same thing with 5, 6, 7. That answer would be 2, 5, 6, 5. You subtract the 2 from the 3, stick it over here. That's 2121 for this answer. If you want the 5, 6, 7 sequence, or 6, 7, 8, it would be 2, 6, 7, 6. But that's the way you can predict the answers right there. Who predicted the answer? Is that you, Sue?
No, that was Shar Pomeroy.
Okay, good for you. On simple addition, wait. I've got to clear this thing. Simple addition left to right. It's reversed on how we learn. Whoop,
Michael, you still need to clear the
sure do.
annotate.
The pressure. All right, simple addition, left to right. It's reversed from how we learned it in school. So how you start is you go 600 plus 200 is 800, plus 400 is 1200, plus 300 is 1500, and 1530, 1600, 1660, 1750, 1751, 700, 1755, 1764, 1772. So you can do this mentally. You see that, right? Versus trying to do this and carry. Everything in Vedic math is mental. A series is numbered. Now this one works, but I don't know how. You add the smallest and largest number, then multiply by 5 and divide by 2. So 4973 is 122 times 5, 610, divided by 2, 305 is your answer. Add consecutive numbers. 23 to 29 has 7 digits. So you add the 2 first and last numbers, 52 times 7, which is the number of digits, equals this, divide by 2, 182 is your answer. And consecutive numbers, 26 to 36 of 11. You add the 2 numbers, and then times 10, 620 divided by 2, 310 is your answer. Again, mental. Subtraction, that's easy to do. You can just round up to 300 and subtract. All right, this one might be of interest. Any digit that you want to subtract from that's a multiple of 1,000, 100, and so forth, here's how you do it. The sutra is all from 9, the last one from 10. So you take 6 from 10 is 4, 2 from 9 is 7, 8 from 9 is 1, 4 from 9 is 5, 7 from 9 is 2. That's your answer. So you can do that. You can see how you can do that mentally, right? And on a smaller number, you can ignore trailing zeros. So 6 from 10 is 4, 5 from 9 is 4. Number of zeros must equal a lesser number. So if you have something like this with 2 digits from a 4-digit number, you add the 0 and then minus 1 from the 7,000s. So 9 from 10 is 1, 4 from 9 is 5, 0 from 9 is 9, 1 from 7 is 6. All right. Any? Can you do the below subtractions problems mentally? Yes, very easy to do. Once somebody shows you how to do the jump shot, you just got to practice. Here it is. It's 500 from 300 is 200, and then 36 from minus 43 is minus 7. So your answer is 193. And likewise here at 7,000s, the same way you do as you did on the addition, adding up from left to right, you subtract from left to right with 5,000 from 7,000. And then 400 from 800, and then 89 from 92 is 3. There's your answer. And likewise for the 5-digit numbers, same thing. You divide again, 11 and 9 and 5 are magic numbers. Divide by magic 9, add from the left, drop the 1. So 1 is dropped right down here. You add 1 and 2, which is 3. 3 and 1 is 4. 4 and 0 is 4. 4 and 1 is 5. And then 5 and 1 is remainder of 6. Your 9, which is 1 below 10, so you're going to add to get to 10. Just as a memory trick. The next one, on this particular one, remainder, if you had a 9 in this number here, the remainder then would be 5. When you do this, you can tell what the remainder is before you even divide the number. How many 9s? You got 2 9s in this number, then the remainder would be 4. All right, divide by magic 11, you've got to subtract, drop the 2, then 2 from 4 is 2, 2 from 6 is 4, 4 from 7 is a remainder of 3. Any number you divide by 11 always has a remainder. Divide by magic 5. 64 divided by 5 is 128. And how you get that is you just multiply by 2 and divide by 10. When you do this, you just move the decimal points in one spot. Divide by magic 5s. When you divide by 5, any number you multiply by 2 and divide by 10. If it's 25, multiply by 2 twice, divide by 100, and so forth. 49 divided by 5 is 98. Divided by 10 is 9.8. 103 divided by 25 is 103 times twice. 412 divided by 100. When you divide by, again, 5s are 5, 9, and 11 are magic numbers. 71 you divide by 25 is 284, moving the decimal point over 2 places. All right, let me just continue. And by 125, you have 3 multiples of 2. Squares and square roots are phenomenally easy. If you happen to have a bunch of 3s and a 2 like this to square, your answer is this. 5 3s, then you get 5 1s, then 0, then 5 2s. Then you square the 2. That's your answer. With 6 3s, that would be your answer. With 6 1s, 0, and 6 2s, square the 2. Squares ending in magic 5. The square of 75 is 7 times its superior, which would be 8. 56, you drop it, then square the 5. So your answer is 5625. You see how you can do this mentally, right? 35 is the same way, 3 times its superior of 4, same essence. 115 squared is 11 times its superior, 12, equals 132. Drop the 5 squared, 132, 25. Even bigger numbers, 78 times 79 is this. You drop this number, then square the 5, and that's your answer. You multiply the 10s or 100s number times its superior. Any number to be squared that ends in 5 always has 25 as its last 2 digits. If you square a number in the 50s, which is very simple to do, you 53 squared, you add 3 to 25, drop it, and then square the unit digit, which would be 3. So that would be 2809 is the answer. 56, you add 6 to 25 and drop and square the unit digit 6 with the carryover of the 1. So it's 3136. You got to square 2-digit numbers. Here's one way to do it quickly. Use the base of 10, so 10 minus 14 is 4. Then 14 plus 4 is 18, drop 4 squared is 16, drop carry 1, which is 196 is your answer. All right, there's another way to do squares on higher numbers. This will be in the package if you want to email Mark at the end, and he would send this to you. I don't want to spend time going over all the thing. This one might be of interest. 34 squared. You square each number, 916, and then 3 times 4. So you multiply the 2 digits times 2. Then in the hundreds, you add in the hundreds. So 916 first, and then 3 4s are 12, 2 12s are 24. Add in the hundreds. Here's your answer. Likewise down here. Again, when you square 2 digits, this would be a way to do it just a different way. There's several ways to do this, all of them mental. This one is, you can square each digit, 36 and 16, multiply the digits times, which is 4 times 6 is 24, then double the 48, add to the middle digits, and that's your answer. The key on
Michael, can we pause a moment to see if there's any questions from anyone?
Sure, absolutely.
Yeah, folks, if you have any questions, feel free to unmute yourselves at this point.
I have a question. I'm just wondering, and I've been trying to follow, I know you're going quickly because there's a lot to do, but I've been keep testing out different things as you're going along. When you say you have to teach yourself this, it seems to me like this is a lot of tricks, and there's different tricks based on what you're trying to do, which I totally appreciate and understand the importance of. But is there an overall, like you said, the magic 5s when you're squaring a number that ends in 5? That particular method works just for that condition, like for that particular situation. Are there overall things that will work for any situation, or is it a matter of knowing a series of different methods?
Well, there tricks is another word for sutras.
Yeah, I understand. Yep, tricks isn't a bad word in my opinion.
Well, I know there are, except when you're dealing with the 50s, as you square any number in the 50s, that's a unique situation. 5s are unique, 11s are unique, 9s are unique. So it's different than normal. If you're squaring any number, as an example, this would be how you would do it. I'm not sure I answered.
Typically, when I taught middle school, I would teach my students to recognize patterns in numbers and come up with some of these tricks, sutras on their own. Is that more what this is about, like teaching yourself to recognize the number patterns? Or are you advocating that students sort of keep these tricks in their back pocket?
Well, some of these sutras don't work for large numbers, so you'd have to use a different sutra. And it's essentially, when you look at the problem, immediately you got to yank in the sutra that you believe will work for it. So that's the remembering skill that's got to be acquired or better. Does that answer your question?
It does. And just curious, will these slides be available to us, Mark?
Yes, I'll be emailing the presentation to everybody who has registered for today.
Great. Thanks so much. Thank you.
All right. 32 squared is easily done. you square each number, and then you got to find the middle number. So and then 2 times 3 is 6. This works for the lower number. So it's a procedure for that. When you square 3-digit numbers, the answer of all numbers 316 and below have 5 digits. Those above have 6. It has a base of 400. So that's 12 is 424 times the base, which is 4, gets you 1696, which you drop, then square the 12. 144 in hundredths, and drop last 2 digits and add. So that would be 1696 added to 144 with the 1 and the 6. That's how you would do larger numbers. The base on this is 200. Remember I said you got to know the base you're in. Remember that. The base is 200 minus this. So it's a -4 from the problem number. It's 192 times the base, which is 2, equals this, drop, and then square the deviation, which would be 16, and drop. So that would be your answer. 291 would work much the same way. When you square three numbers that are big, I mean 3 zeros, so you would subtract from 974 from 1,000, the base, get 26, subtract that, and then square 26 and drop that. So when drop occurs, you don't add, you just drop the numbers. And that would be your answer to a 3-digit square. Again, this is another way to do that. I'll leave this for the, and this is I think the easiest one. Square each number. So 160009. That's your squared number, and then you 3 4s are 12, and you double. It's 24. That's your answer. So for large numbers, this would be the one I would pick. And again, this is the same for large numbers. And this is a way to square each number, and you got to carry the 6. And that is your answer, squaring 825. So you got to look at the problem, and then yank in the category that would work best for it and you. And this is, you can score any number from 1 to 100 to 200. It's right there. This one's boring. All right, now we're going to get into cubes. Only 4 types of numbers can be cubed. Here's the example of each one. 12 cube is the first type, has 2 spaces after the number. You square the 2 and drop, then 2 cubed, so 1248. Then you double the 2 and the middle number, then add to the square and cubed numbers above. So this was the first number, and you double the middle 2 numbers, and that's your answer. Again, you can do this mentally with a little practice. The second category was reverse the game. There, 21 cubed, you have the number tailing, and then you follow the same procedure, double the 42 to 84 and add to the middle numbers. This is the interesting one. 22 cubed, so it's the same 2 digits in the problem. You just cube it once and then write it 4 times. And then you double the 2 digits in the middle and then add to the middle. And that's your answer.
Excuse me, I'm just curious. I get the type 3, it's the same number twice. Can you explain a little bit more about the categorization of type 1 and 2? Like what would put a number in the first 2 types?
What it starts with.
The fact that it starts with the digit 1 or starts with the digit.
Yes, it starts
okay,
with.
I get it.
It starts
Sorry.
with 1 or ends with 1.
Got it. Thank you.
All right. Any questions, just ask. I'm trying to I've got to be as brief as I can and still hopefully get you guys excited to do this.
You're doing fine on time, Michael, so just so you
Okay.
know.
All right, thank you. And let me get back to the fourth type. This is the fourth type. Let me get, sorry. All right, this is the same, this is the really easy one. 88 was a number. And so you just square the one of the digits and write it as such, and then double the 2 in the middle, and then add. The fourth type, when the two numbers are different, you can just follow this along and then add much the same. Although here you got to carry, but you also can do that mentally once you practice enough. Here's a different way to cube that's fast. And yet again, a different way to cube that's fast, depending on what's the most comfortable for you guys. And here's a fairly big one that's a little bit complicated, but again, it's another one for cube. Now the square roots are a snap. The square root of 87 would be 9.33. So the 95 or whatever it might be that you have to find the square root of, you just simply get the closest one that works. Like if it's square root of 87, 9 is the square root for 81. 81 less from 87 is 6. Then double the 9, which is what the square root of this is. That equals 18. And then you have the difference over 18, which comes out to square root of 87 is 9.33. Any questions on that? You can do this. You can do this in 2 or 3. You see how easy mentally this would be to do. You can do it on 3-digit numbers with an extra step that I haven't figured out yet, but it's very easy to do. All right, this is just how you multiply numbers below. So you can see how you can add the 0, get this, then you add and get the answer. Again, multiplying those two numbers together, you can do mentally. This is just basic. Again, just how to more multiplication sutras that, depending what makes you more comfortable, you can use. And this is multiply two numbers, 2 times 4, 1 times 3, 8 and 3 drop. But you split them, and then you cross multiply. 2 times 3 is 6, 1 times 4 is 4. Then add to the middle number, which equals, you add them. You add this and it gets to the middle, which is 10. So you got to carry the 1 because there's only one digit there. This is just a base of 20, a different way to do 2-digit multiplication. Again, a different way to do that. This is the only thing that you got to remember on this is a base of 20, so you're multiplying by 2. Base of 30, you multiply by 3. 76 times 98, this is how you would do it. 7 times 9, 6 times 8, drop both, 63, 48, then add the sums of the below. 6 9s and 7 8s, 56 in this, 110, add 0 for 1,000 base, and that would be your answer. You multiply any 2 digits, this would be a different way to do that. The first thing is 4 times 6 is 24. 4 times 3 is 12. 2 times 6 is 12. So it's 12, 12, and then you do the bottom, which is 30. And this is your answer. Just more how you can multiply 3-digit numbers. with the bases. All right, this is multiplication of magic 5. So you're going to multiply this number, this $1 million number, by 5. You add a 0 to the end, divide by 2. So you actually, adding the 0, obviously you multiply by 10, and then you cut in half. This is your answer. Multiplication by magic 9. There's a number you want to multiply, you add a 0 and subtract the original number. That you can do mentally. On this one also is a way to do that. This takes some practice. All right, this is how you would multiply this big number by 9 million out there, and this is your answer. You take the the multiplier, subtract 1 and drop it, and then you subtract the multiplican from the number and drop it. So this would be your answer. This one you got to do a lot of practice to remember all the digits, but that could be done mentally. Now multiplying by, we just went over some of the 9s, multiplying by the magic 11. 11 times 52 is add the 2 digits together. 5 and 2, 7, that's your middle number. That would take 3 seconds to do, but that's not fast enough. Again, if you multiply 53 by 11, your answer is 583. If you multiply 62 by 11, your answer is 682. All you do is add these 2 together. The 1 second to do, if you have a 6 or a 5 on the tens digit, add that to the number. 6 plus 2 is 8, so your answer is 682. That takes 1 second to do. All right, so this is a way you can see that more. On multiplying this number by 11, you drop the unit digit, and then you add 2 to 3, 5, and then 4 to 2, 6, 1 to 4, 5, and drop the first digit. So your answer is 15653. That's again a magic 9 or a magic 11. And here is the same thing. Drop the unit digit. And 6 plus 9 is 15. It's 5, carry 1. 6 plus 7 is 14, carry 1. 7 plus 2 is 9, carry 1. 2 plus the carry 1 is 3. So there's your answer. Again, drop the unit digit. 9 goes down. And then you add 3 to 9 is 12. 5 and 3 are 8, plus the carry of 1 is 9. 2 plus 5 is 7. Drop the 2. And this is just more of that. When you're doing 3-digit, like 111, again, 11 is a magic number. You split the number you're multiplying by 111, and then add them together and put them there twice. So 26 would be 2, 8, 8, 6. 34, 3, 7, 7, 4. And when you do 4 numbers, 4 11s, 1,111 times a 2-digit number, you need 3 digits in the middle, and this would be your answer by doing the same procedure. Multiplication by 12 is pretty much the same way. Here's the 2 right there. So if you drop 5 and each number added to 2, add it, each number times 2, sorry, and then drop the drop the 04. Multiply by 13 is the same. You got to multiply it by 3 though. By 15, again, ends in a 5. So divide by 2 is 6. 12 plus 6 is 18 times 10, 180. And here's how you do it with a larger number. Sorry. Multiply any 2-digit number. You take the number 97, divide by 8 times 1,000. So your answer is 12.125. And then that's the divisional number. Then you multiply times 1,000 and you get the answer. With this, in this case, 125, you always divide the number by 8. Well, the palindrome is, I'm sure you guys know, a word is spelled either way, backwards or frontwards, in the same way. In math, this is how you can do multiplication in your head faster than a calculator. You first take these two numbers in the vertical. 6 times 8 is 48. So that, leaving 8, carry the 4. Then you got to cross multiply. 3 6s are 18, 5 8s are 40. So that's 58 plus the 4 carry is 62, leaving 2 to carry 6. So that's 228 is the answer. Step 3 is the left vertical. 3 times 5 is 15 plus the carry of 6, leaving 21. This is the origin of the multiplication symbol used in our Western multiplication according to what I read. And this is how you would do 3-digit multiplication. Anybody want to give it a try? This is a badly drawn model. 3 6s are 18. Now you got to cross multiply. 3 5s are 15. 2 6s are 12. That's 27. Carry the 1 from the 18. That's 28. Carry 2. Now you got to add the 3 multiples. 3 3s are 9. 4 6s are 24. That's 33. 2 5s are 10. 43. And carry the 2 from the 28 for a 45. Then the 2 6s are 12 and 4 5s are 20. It's 22. Carry the 4. I'm sorry, I forget the carry. You would carry the number over to a 0, and then 3 4s are 12. Carry the 3, and that's your number. It's fairly easy to do with a little practice. This is just, again, the reason that you might, for a job interview, or your kids or grandkids or nephews or nieces, if they can walk in at the interviewer and when he asks, what else should I know about you? You can say you can multiply 2 or 3-digit numbers mentally faster than he can use a calculator. That's going to be a significant differentiator between all the candidates that they're looking at. These would be the websites that you could continue, if you want, with Vedic mathematics. This is the one you want to look for on the web, and these would be the apps on the iPhone. Any questions?
Feel free to unmute yourselves, folks, if you have a question.
Would you mind going back about 4 or 5 slides to the 2-digit multiplication?
Right
Yeah.
there?
Sorry, can you just redo this slide for me? I found it interesting, but I couldn't quite follow.
All right, this is done mentally now, right? So you do the first vertically. That's 6 times 8, 48, carry the 4. The next step would be cross multiplication. 5 8s are 40, 3 6s are 18, 58 with a carry of 4, so that's 62. And then 3 5s are 15, carry 6 is 21.
Got it. Great. Awesome. Thank you.
Sure, you just follow the badly drawn diagram here.
No, I
So-
like the diagrams, especially for the 3-digit one. Made it a lot clearer.
Yeah, that's, I couldn't get these things to line up, but you can see, you can do this mentally, and I have when I'm not under a lot of pressure. But it's really something to do, and you see somebody do it, and it just wows you. But this is the ones you can spend hours and hours going all of this, and it goes up a lot more than just multiplication, as we've shown a little bit here. Any other questions?
Yeah, I'd like to thank Shar for her questions. I think she's added an interesting perspective. I can see that I have a whole lot of work to do to understand this, but I do plan to go out to these websites and start playing around. Thank you.
Well, you're welcome. For the kids, having these on their iPhone would be a lot better than some game that they're doing. But that's a whole different, how you do that, how you make that happens. Very tough.
Well, and I think for to present these to kids, I think we need to just throw one thing at them. They love tricks, right? So you throw one of them at them, that gets them excited. Maybe a week later you throw another one at them. But I agree. And I'm sure the apps are like any puzzle app they do, right? It will, some of them will latch onto it. Maybe not every kid, but some kids definitely will.
Well, yeah, absolutely right. That's the mistake I made when I first got into this. I did everything at once. And I got so confused, my head hurt. So you got to go back and do everything sequentially.
That's how my head's feeling right now. But I know once I look into it more, I will find some parts of it. I mean, I already love parts of it, definitely.
Oh yeah, some of that in the multiplication things, there's about 5 or 6 different ways to do it. And you want to look at it and pick one you like. And then I would say stick with that. But they've been doing this for 800 years. And what I've read, apparently, if you get you get a banking job over in India, they're required to learn this and know this because it's a fairly prestigious job. But I've seen the chairman of the board of Sun Microsystems, Vinod Khosla, did this in real life, and a couple of us just couldn't believe it when he's doing 2-digit multiplications mentally faster than you can use your calculator. That's very impressive. Any other questions? All right, if you
Again, we'll be emailing the slides out to everyone who has registered for today, and you'll be able to find the video from this morning up on the library's YouTube channel a little bit later this week.
Okay, well, thank you guys for attending.
Thank you, Michael, for presenting.
Thanks, Mark.
Thanks, everybody, for coming.
Thank
Enjoy
you.
the rest of your day. You're welcome. Enjoy the rest of your day now.
Bye-bye.